Alright, so this is the web service. This is the PHP code that runs the web service. A few different scripts here. Super simple. So this is the receiver class. I don't think these descriptions are accurate anymore. I haven't gone through and rewritten them and commented this stuff, but super basic class. It's listening, script. It's got listening for these get parameters, the name of the command, the value for the command, and the device. So for example, this could say garage, and the value would be open, so garage open, and then the device that you're sending it to would be like garage Arduino or garage controller. This, as the comments say, checks to see if a command exists in the table. If it does, it updates the value for the command, and if it doesn't exist, it enters the new command, and it just stores those three things with a command ID. And then this command here, this makes a call against my sender script, and the sender script actually sends the device the command. That could be in one script, probably. This could just send the command to the device in the same script. But I had other ways of implementing this sender that I don't know yet. I haven't planned it out yet, but so for now they're separate because I might implement using this to send commands without having received them through this interface. So that brings me to the sender class. Basically, it just listens for a device. So it gets the device ID. So like this calls, let's say you're sending the garage open command to the garage controller. That'll send garage controller to the sender script. That's going to look up all of the commands. First, it's going to look up the IP address of that device with its alias. Once it gets the IP address, it's going to look up all the commands for that device, and it's going to send those commands to the device. That's what this is right here. And it sends the command in the format name value of the command, so as get parameters, as a get parameter. This iptabler script lets devices register when they first connect to the web service. They register with their IP address and their alias. So it's listening for the name and the IP address. So all the clients that I have, like the Arduino, the ESP8266 Wi-Fi chips, the desktop client, etc., they all connect to the internet and then register whatever their local IP address is that they get from my router. And they say like, okay, I'm the garage controller, here's my IP address. This is stored in the IP lookup table. So whenever you send a command, I can get the IP address for the target device like that. I wrote another script that has a pretty limited direct function, and I'm going to try to make this more flexible, make it kind of configurable, and maybe make an interface where you can add these cameras. But basically this is just going to, it waits for a camera name, and I have the three that I currently have connected to my network hard-coded in here. So that's what I don't like, is that it's hard-coded. I'm going to try to make this configurable and reusable and things like that. But for now, for testing and for development, I have it hard-coded that if I send garage, front driver, backdoor, it returns, the IP address is set to the IP address of that IP camera. And these I made DHCP reservations for in my router, so these are never going to change. Basically, it takes the IP address, puts it into a URL, which I have redacted from this script temporarily because it has my authentication for these IP cameras in it. And but it just has the IP address that has the authentication username, authentication password at the URL that the D-Link cameras use. I use D-Link store-bought, D-Link IP cameras. They have a built-in server that offers these different URLs for different feeds. You can get the MJPEG, you can get the JPEG. In this case, I'm just getting the JPEG and just kind of passing it through. So basically, this page has become a web server where I can get the view from any camera by passing the camera name. And it gets just the static JPEG, which made it easier to use them for other stuff. In the clients that I have that actually use video feeds, it basically makes this request repeatedly, and it performs pretty well. I was actually worried about it, but I think it performs well for my purposes. I mean, it's a few frames per second. It's a little choppy, but it's plenty to get a general idea of what's going on in that camera view.
So yeah, like I said, I removed the line that has the IP address, but it's basically just a pre-configured D-Link
URL that they use for their cameras. These two classes, this cam feed web interface, that's what the WI is, receiver web interface, those are both basically the same. They're duplicates of these, but they're in a folder that requires HTTPS. And the reason I have them separated is because on my local network, especially with some of the clients I was using to communicate, some of these microcontroller clients and stuff I was using to communicate with these scripts, implementing HTTPS properly is difficult to do. And with the fact that I'm running a home server that I'm exposing to the web, when I do the Android client or desktop client in Java, they want, real certificates. So I'm using a self-signed certificate, which I implemented for those two clients because they're going to be the ones that are accessing this remotely. And I want that encrypted, obviously. But as far as the local communications that are happening on my Wi-Fi network that's WPA2 secured and stuff, I don't need them to be encrypted. I'm not worried about it. And implementing HTTPS properly with a lot of these clients was more difficult than it was worth. So what I did is I duplicated these two classes, HTTPS, in an HTTPS folder, and then these two are the ones that I'll actually communicate. The rest of these are all inaccessible from anywhere outside the local network. These are accessible from globally from the internet through port forwarding, but only through an encrypted and authenticated connection. And that is a general overview of the PHP code I have so far. It's been working pretty well polished. This is all running on an Apache server that's running on this computer that I'm actually working on right now. And it's got a static IP address, and it's has global HTTPS traffic forwarded to it. Next, I'm going to take a look at the current iteration I have of my desktop client and my other clients, Android, stuff like that, and I'll go into some of the hardware.